This is the last lesson of chapter 3, function notation. This is out of order in the workbook. It's technically section 5.5 in the workbook, but we're doing it as the last lesson in chapter 3. Function notation is a way to represent functions, and it's written as f and then in brackets x. This is pronounced f of x. So you kind of pronounce the brackets like the word of, f of x. So for example, here we have f of x equals 2x plus 1. This is very similar to our linear equations we've seen before that might look like this. Essentially, we've just replaced y with f of x. And it's meaning the same thing, but f of x is easier to work with. This function notation is easier to work with because we can easily calculate what the function's value is at a certain point. And we're kind of treating it like inputs and outputs. So some examples. Given this function, f of x equals 3x plus 5, determine the point on the line for f of 2. In other words, if we have f of x equals something, and now we want to find f of 2, we are replacing x with 2. We want to know what the value of this function is when x is equal to 2. So we want to find f of 2, and we write the exact same equation that we have here, except we've replaced, in brackets, we've replaced x with the value that we were given here, which is 2. And then we just calculate 3 times 2 plus 5 gives us 11. So the point on the line for f of 2 would be the ordered pair 2, 11. Why do I know that the 2 goes first? Because we were given that x equals 2. Because we know that it's f of x, and we were given f of 2. So the x has been replaced with a 2. And then we just calculated that this is equal to 11 on this function. 11 is the equivalent y value of the ordered pair. So that's one way we might use function notation when we're solving for the y value or the f of x value. We can also solve the other type of equation. So in this second example, we have the same function, but now we want to determine the point on the line for f of x equals negative 7. So in this case, we don't know what x is, but we know that whenever we sub that unknown number in, we get negative 7. We want to find what that number is. So we take our original function, 3x plus 5, and now instead of replacing x with the number that you have, you're going to set this whole function equal to the number that you have. The reason this is true is because we're given that f of x equals negative 7. So we take what we had originally and just replace f of x here with that number, negative 7. So it's going to be negative 7 equals 3x plus 5. And then we solve. So we would first minus 5 on both sides. This is grade 9 material, so you should know how to solve for x. Minus 5 on both sides, we get negative 12. And then to get x on its own, we would divide both sides by 3. So we get x is negative 4. So again, the point on the line would be the ordered pair negative 4, negative 7. I knew that negative 4 went first because we just found that x is equal to negative 4. And I also know because f of x is kind of the equivalent of our y, and we were given that y, or f of x, is equal to negative 7. Another larger example here, for the function f of x equals negative 5x plus 3, the first one is we want to find f of negative 2. So f of negative 2, we would write the exact same function now down, but then replace the variable x with the number that we're given, which is negative 2. And make sure you replace it in brackets so that you have the correct sign. So when x is negative 2, we would get 10 plus 3, we would get 13. So f of negative 2 is equal to 13. It didn't ask us to write this as a point, but if it did, that would be the point. That's our x and that's our y. Second example, we want to find f of m. So now we don't even have a number that we're replacing it with. We're replacing it with another variable. So this is easier than it sounds. F of m is just the same linear function, except you've replaced x with whatever's in the brackets here, which happens to be m. And then there's nothing else you can do for this. There's no calculation you can do. We just leave it as negative 5m plus 3. And then the last example, we want to find f of x equal to negative 10. In other words, what does x have to be equal to so that when you sub it into here, you get negative 10? So to solve this, if f of x equals negative 10, we take whatever the function was and set it equal to negative 10 and solve for x. So we minus 3 on both sides. we get negative 13. We divide both sides by negative 5. Our final answer would be positive 13 over 5. And you can just leave it as a fraction. So in summary, when you're given a function and function notation, you can solve for either x or f of x, where x is the input and f of x is the output. And you can remember that because if you have this here, x is inside the f. You're subbing in x to this function and you're getting a certain value from it. So x is the input and f of x is the output. If you're given f of x equals any number, like this example here, f of x equals 1, let's say, just replace f of x with that number and solve for x. So we're given that f of x equals 1 for this function here. So we just replace this left side of the equation with 1. Now we have 1 equals 2x plus 3, and we solve like normal to get a value of x equals negative 1. The other type of question you might see is if you're given f of any number, like this example here, all you have to do is replace x in the function with that number and solve. So we're given f of negative 3, take the original function, replace x with that number in brackets, and solve. One last example. In this case, we're given a graph. So from the function on this graph, determine the domain and range, calculate f of 3, and calculate x when f of x is negative 3. So this is easy. It's a linear function with arrows on the end. So our domain and range are both all real numbers. It can be any x and any y. To determine f of 3, this is the function when x is 3, because we've replaced x with 3. So we want to go on the graph and find right here, when x is equal to 3, what is the function equal to? This is why I've drawn these dotted blue lines to kind of show my vision here. At 3, I go up until I hit the function, and then I go across until I hit the corresponding y-axis or the f of x axis. In other words, the output. So the function when x is 3 is at about 1 half, between 0 and 1. And then the other thing we wanted to find is calculate x when f of x equals negative 3. So when f of x is equal to negative 3, this is when the function is at y equals negative 3. So we go to the vertical axis here when y is negative 3, or when f of x is negative 3. And we draw a line, imaginary line, across until we hit the function and see where that is at on the x-axis, which is about negative 4. So to summarize, f of 3 is equal to 1 half. And when f of x is equal to negative 3, this happens when x is equal to negative 4. So we can find the corresponding points using function notation.